Okay everybody, all sorts number 10. This question is not so bad once you've managed to do the balancing. Part B is actually a simple reacting mass calculation. Imagine quote marks around simple once you've got the ratio from the question. So what I've gone ahead and done is I've written out the equation that they've given to us, and then I've got a little bit of working ready. So I've written out the elements in order on the left and on the right hand side so I can count them up. This is a balanced equation that I need to do this for. It is not an easy one. If you can do it in your head, then well done. But the majority of people, I would imagine, would need to do the working. So don't feel bad if you found it difficult. So first of all, I'm going to just add up how many elements we've got on each side. So we've got one aluminium, one nitrogen, 4 hydrogens, 1 chlorine and 4 oxygens. And on the right hand side, we've got 2 aluminiums, 2 nitrogens, 3 hydrogens, 1 chlorine, and we've got 4 oxygens. So it might be tempting with this one to go straight in and say, okay, I've got 1 aluminium on the left and 2 on the right, so I need to put a 2 there that will balance it out. But that doesn't help us balance anything else. So that is not the first place to start. The same goes for nitrogen. If we were to say, oh, okay, I've got 1 nitrogen on the left-hand side and 2 on the right, so I'm going to put a 2 here. If we go along that route, what you'll find if you try that, that won't work out either. So sometimes you have to ignore the simple route and you've got to go down a slightly more complicated route. And the way that you can do this is to look for lowest common multiples. And that's what I'm going to do first. So if we look at the hydrogens, the lowest common multiple, in fact, I'm going to do it just here. The lowest common multiple is 12. And that's what we're going to look at first of all. Okay, so how can we get 12? Well, we need to have 3 over there. What that will do is give us 12 hydrogens. Okay, and it also gives us 3 nitrogens. It gives us 3 chlorines, and it gives us 12 oxygens. And that looks like we've done something slightly weird to begin with, and we have, but it will work out in the end. Now the next thing to look at is, well, where do we go from here? What do we look at? And you might be tempted to look at the oxygens because we've now got 12 and 4, which gives us kind of a ratio of times by 3. But because we've got oxygen present twice on the right hand side, it's not going to be the easiest way either. So what can we do instead? Well, I'm going to look at the nitrogens because we've already said that the aluminiums is not going to help us to begin with. The chlorines, well, if we change the chlorines, then we've got chlorine that we're then going to change the number of hydrogens twice. That's going to get confusing too. So nitrogens is what I'm going to look at. And again, I'm going to look for the lowest common multiple. Now the lowest common multiple of 3 and 2 is 6. Okay, well, how do we get 6 nitrogens on the left-hand side? Well, okay, we've got to change what we did previously. And we are going to change to put that like that. Okay, so I'm going to change that to be a 6. That gives us 6 nitrogens on the left-hand side, and by putting a 3 in front of the nitrogen molecule on the right-hand side, we get 6 there. Now, obviously, on the left-hand side, I've changed some other stuff as well. So I've got 6 nitrogens. I've now got 24 hydrogens. I've got 6 chlorines, and oxygens, I've got 24 as well. So we've now changed a whole load of stuff. So what can I do that's fairly simple now? Well, the first thing I'm going to go into doing is the chlorines, because chlorine is present once on the left and once on the right hand side. So I can do this fairly simply. I put a 6 in front of the HCl and I get a 6 just there. Okay, so that's the change that I can make first of all. What else have I done there? Well, I've got my hydrogens now got 8 on the right hand side. So where do we go from now? Okay, the next thing I think to look at is going to be to think about these hydrogens. The hydrogens, we've got 24 on the left in total, and we've got 8 at the minute on the right. But what we're going to do is I'm going to take the 6 that we've just done. I'm going to take this 6 here, and I'm going to pretend that we're only looking at the 2 hydrogens that we've got here. So we're just going to ignore the hydrogens that we've already just balanced, the 6 HCl. And we're going to think, right, well, how many have I got to balance now? If I ignore the 6 on the right-hand side from the HCl, I'm also going to ignore 6 over here. So 24 minus 6, okay, that comes out to be 18. So there are 18 hydrogens on the left-hand side that are currently not balanced out on the right. So this H2O, we've got 18 hydrogens we've got to balance. So it's actually going to be 9 H2Os that we need. That 9 H2Os then sorts us all out and gives us, in the total, 24 hydrogens, and they are balanced. By doing 9 H2O, we've then changed the number of oxygens that we have. And the number of oxygens that we've got in total now, hopefully, well, we've got 9, we've got 12. Okay. The oxygens and the aluminiums are the last thing we've got to balance. We've got to balance out the oxygens. We've got 12 in total at the minute on the right-hand side, but we need 24. So again, like I did before, I'm going to say the 9 that we've just put in the waters here, we're going to ignore. 12 minus 9 is 3. So we're just going to balance the 3 from the Al2O3 and ignore anything else. So 24 minus 9 is 15. Okay, that 15 is what we need to balance with the aluminium oxides. The 9, remember, have already been balanced by the 9H2O. So if we're looking at 15 to 3, then what we need is 5 aluminium oxides, which gives us 10 aluminiums, and therefore we need 10 Al on the left-hand side to give us 10. And that is the correct answer. Now taking that and moving on to part B, where they're asking us to calculate how much or mass of HCl, if 160 tonnes of Al, okay, that's the question, we've got to use the ratio. The first thing that we're going to do is we can work out the moles of aluminium. This is a straightforward mole calculation. So moles is mass over relative mass. Okay, the mass, however, we've got to consider tonnes. 1 tonne is 1,000,000 grams. 1 tonne is 1,000 kilograms. 1 kilogram is 1,000 grams. So this actually is going to be 160 times 10 to the 6, or 160 million, divided by the relative mass of aluminium, which is 27. We don't use the ratio. If we put that into the calculator, it comes out to be 5925925, and then that just repeats over and over again. So we've got the moles of aluminium. We want the moles of HCl. What's the ratio? Well, it's 10 to 6. So the moles of HCl is going to be moles of aluminium divided by 10, that would give us 1 here, and then times by 6. And if you put that all in the calculator, 5925925.9 divided by 10 and all times by 6, it comes out to be 3555555.5 recurring over and over again moles. So mass of HCl is going to be moles times MR, 3555555.5 recurring, times the MR of HCl, which is 36.5, that's 1 for H and 35.5 for Cl, and that comes out to be 129,777,777.8, which is grams. And we can put that as to 3 sig figs, divide by 1,000,000 to give kilograms, but it's not necessary. And there we go.